Okay, so this is our ABE project. It's a 2D Truss calculator. I'm Evan Wolfson and my partner, Steve, aka John. We both worked on it and it took a long time, and this is our video. Okay, so this is the main page. This is what you see when you open the document. This is where everything starts from. You can see that all of our forces and angles from the forces are on this page, and they're pretty easy to read. We have a slide bar at the top that lets you select the number of members on the truss joint that you're calculating forces for. We also have the graph there at the bottom right that describes all of the angles of the joints and the forces associated with them. We have a couple buttons here. One's to randomize the data. That button just pulls up a form that lets you enter in limits for the forces and the angles, and it just randomizes everything. The calculate equilibrium equation is the main thing in our form. It pulls up its own user form where we can calculate the unknowns and enter in all of our own forces. In addition, we also have the show and hide graph options. Okay, so here's the form that pulls up when you click the calculate equilibrium forces. In this form, we have areas where you can identify the number of members, the external forces, the angle of the external force. You can randomize the data, calculate, reset, close, all that good stuff. And it also has a diagram that changes according to how many members you have selected. So when you have 3 members selected, you'll see a diagram that appears with the 3 buttons there, as well as text boxes that allow you to enter the angle and the force. The bottom text boxes for the forces associated with the members, and the top boxes for the angles. When you click on one of these buttons, the actual members themselves in the diagram, you can designate them as unknowns, and that's where that little yellow FA and FB box comes up. You know it's an unknown force because this box appears. Once you have designated angles and forces for all the members that you have selected, you get this, and you calculate, you'll get this extra little message box that tells you the unknown forces, and these are also displayed in the bottom left of the main worksheet. If you only have one unknown force, then you get this message box, and this will also tell you the unknown force associated with that. As well as this, there are also several different errors messages that we have associated with everything. This one in particular is if you have more than 2 unknowns. Since we only have 2 equilibrium equations to work with, since it is a 2D equilibrium, we can only have at most 2 unknowns. So when you have too many unknowns, this dialog or this message box appears, and it'll take you back to the main user form once you hit OK. If you have no unknown forces, then you get this dialog box, which you need some kind of unknown to solve for any unknown forces. Otherwise, this would be kind of superfluous. If you hit random data, you get this little dialog user form. And basically this allows you to enter a upper and lower bound for angles and forces. This is just basically if you don't really have any particular forces you're solving for, you just want to see an unknown or some kind of randomization. You can really just use this to check the program if nothing else. It's just kind of to a check for everything. And there are several message boxes that are associated with this one as well. If you enter a higher bound that's lower than your low bound, there's an error box associated with that for the angles and the forces, as well as if the high bound and low bound are equal, there's this message box for that. This is if you hit the reset button, it resets the external forces to 0, it resets the number of members to 1, and associates the diagram with that, and also resets all of the angles and forces associated with the members to 0. In the main user form, or the main worksheet, the graph can be hidden and revealed using the show graph and hide graph buttons. And that's just for user ease. Sometimes it clutters the page if you have a graph up, so we figured it'd be nice to show and hide it. And that's when it's shown. And this is after the reset button was hit, so all of the angled and member forces are all 0. So this is the graph describing that. This is our calculations page. This was to find the unknowns. In the red is our calculations for if there are 2 members, or I mean 2 unknowns. Basically, the script will see the top left, A2 to A5, with the force of the members, and A6 with the force of the external forces, if any. And B2 to B5 is the angles associated with the members, and B6 is the angle of the external force. Once this is seeded, all the information is changed to a equilibrium expression on that bottom comp sort of table, and the unknowns are seeded into E3 and E4, and then change the radians in the box next to that. After that, they're changed to matrices on the top right table, and go through a couple matrix calculations to get to the final unknown. In the one unknown variable situation, basically you can solve for the unknown using just one of the equilibrium equations. We use the x equilibrium, and we just get the same value as the x equilibrium in the 2 variables. And here is the storage. Basically this is used to store the info from the randomization. The randomization itself uses 4 next loops to seed information into the white boxes here. The low and high on the right are the lower and higher bounds associated with the angles and the forces, and the external bottom, the force. The middle angles are just for angle forces and external. And this is all the randomization is generated inside the VBA script, so I can't really show you that, but from here, the script is saved to variables, and it's transferred to the main worksheet page and to the text boxes in the user form 1. And that's it. Thank you for listening.